Good afternoon, all, and welcome to our online workshop, Electric System Considerations and Rate Design Options for EV Charging. We're delighted to have you join us today and participate in the discussion. I wanted to share a little bit of background on this event and the larger initiative before we dive into the agenda and our conversation with the panelists. And so, NASEO, we are the National Association of State Energy Officials. We're the member organization for the governor-designated energy offices in each of the states and territories. And we are excited to be working with the U.S. Department of Energy's Vehicle Technologies Office, as well as NREL, on an initiative to identify what states need to prepare for EV infrastructure investment, particularly in light of the pending infrastructure bill. And so we launched this initiative this fall in September with a virtual state EV infrastructure summit. This was a larger event that invited the Department of Energy, Department of Transportation, and EPA, as well as state agencies, utilities, and other partners to share some information on what some of the pain points are that they anticipate in the infrastructure package and get the conversation started about what is needed to support EV investment. And so this workshop is the first in our series of deep dive events that we'll be hosting to explore specific issues of interest to the states. And so we are going to be hosting this as a conversation with a number of the participants. And after this workshop and subsequent workshops on medium and heavy duty electrification and some other topic areas, we will be working with ICF and Atlas Public Policy to assemble an online suite of tools and resources that states can use to plan for and then invest in EV chargers. And so with that, I'm going to take a look at the agenda for our discussion. First of all, we will of course start with a round of introductions and then discuss on our first panel, the grid impacts and electric system considerations for EV charging. We'll then take a short break followed by a session on rate design options for EV charging. And then we'll have a short conversation on next steps with the larger initiative. I do want to make a few notes on the format of the discussion, as well as just some housekeeping items before we get started. The format of this is a bit different than events we've had in the past. We are having a discussion with about 10 to 15 participants who will be on screen. These will include some of the experts who will be given presentations, as well as representatives from states, some charging companies, associations, and others who will then provide some questions for our panelists, share their perspectives, and help to advance the dialogue. We also have an audience of state agencies as well as utilities who are listening into the discussion. For those of you who are listening in, you can feel free to ask questions or provide comments through the chat feature or through the Q&A on your screen. And note that we likely will not be able to get to all of the questions that are asked. However, we will be capturing questions and comments in the chat to help inform the development of tools at the end of this initiative. And then also just a heads up that we will be issuing a survey at the end of the event to try to capture some information on what some needs are, particularly of the states and utilities on the line. And so with that, we are going to get started with a round of introductions. And so we are pleased to be joined by some experts from utilities, the U.S. Department of Energy, state agencies, and charging station providers and associations. The folks that you see on the screen will be participating in the discussion as the participants. And so I'm going to do a round of introductions based on order of my screen. So apologies for everyone if I catch you off guard, but we're going to start with Scott. Scott?
Yeah, great. So I'm Scott Briasco. I'm the manager of electric transportation at the Los Angeles Department of Water and Power.
Thank you. And Husaninder.
Hi, Husaninder Singh. I'm a manager for grid modernization at DTE Energy.
Thank you. And Nick?
Nick Revere, manager of rates and tariffs at the Michigan Public Service Commission.
Paul?
Paul Allen, Senior Vice President, MJ Bradley and Associates, ERM Group.
And Tunde?
Energy Policy Manager with the Maryland Energy Administration. My name is Babatunde Idrisi.
Ben?
Hey, good afternoon or good morning, folks. My name is Ben Kessler. I'm the Clean Transportation Coordinator for the South Carolina Energy Office and the PI for our Palmetto Clean Fuels, which is our U.S. Department of Energy Clean Cities Coalition.
Thank you. And Chris?
Chris Irwin, Department of Energy, Office of Electricity, and then I'm in the Advanced Grid Research and Development Division.
right. And the other Chris.
Hi, Chris Junker, Managing Director for Resilience, Clean Transportation, and Analytics for the Hawaii State Energy Office.
Thank you. And Dylan?
Hi, everybody. Dylan Tucker, Senior Program Manager with NASEO. And also, if anything is going wrong for you logistically during the webinar, feel free to reach out, and I'm happy to try to help.
Christina?
I'm Christina Alston with Georgia Transmission Corporation, and I'm over transmission development.
Thank you. And Marion?
I'm Marion Gold, Senior Advisor with NASEO, formerly a Commissioner at the Rhode Island Public Utilities Commissioner and Director of the State Energy Office. Very pleased to be here. Hi, everybody.
Thank you. Mark?
Hi, Mark Smith. I'm the Program Manager for Technology Integration and Deployment in the Vehicle Technologies Office at the U.S. Department of Energy.
Thank you. And Jasmine?
Hi, I'm Jasmine McAdams. I'm a Program Officer with the National Association of Regulatory Utility Commissioners.
Tom?
Hi, everyone. Tom Ashley, Vice President of Policy and Market Development for Greenlots.
Thank you. Irene?
Yes, good afternoon. It's nice to see familiar faces. I'm Corinne Demet. I'm Director of Market Development and Public Policy for the Eastern US at EVgo.
And Robert?
Hi, Robert Cully, Utility Engineering Specialist for New York State Department of Public Service, in charge of the demand management programs and some of our policy initiatives in New York State as well.
Thank you. And Marianne?
Hi, this is Marian Sorrentino. I'm the Chief of Upstate Rates and Tariff at the New York State Department of Public Service, and I'm involved with our generic EV proceedings and the rates and tariffs of most of the utilities in the state.
Wonderful. And is there anyone that I missed? Well, thank you again all for joining. We're excited for the discussion. I'm going to turn it over to Mark Smith with the Department of Energy to say a few words of welcome. Mark?
Great. Thanks, Cassie, and good morning, good afternoon, everybody. Happy to be participating and to be part of this effort. It's kind of interesting how this grew. Cassie and I and Wendy Defoe from NREL started having some discussions back about December of last year, maybe a bit earlier, about, geez, what are the needs that NASEO is hearing from its stakeholders? What are we hearing from our network of Clean Cities Coalition? So good to see Ben. And our Clean Cities coordinators and their stakeholders, as even with the previous administration, people were thinking about electrification. So we thought, well, maybe there's some toolboxes, we can put together a toolbox of some different resources we have that would help, and maybe have a little workshops. And obviously it's grown beyond anything we imagined, but that's good because it's very timely in a number of ways. And certainly as we look at the goal of supporting the administration's initiative of having 500,000 chargers across the nation, a lot has to happen, right? It's not as easy as just digging a hole and putting in EVSE equipment. And so we want to make sure that we're ready, as we know all of you are, when the time comes that we're ready to hit the ground running. And so this is important for us at the Department of Energy. I'm happy to see my colleague Chris from the Office of Electricity on, because the work we're doing at DOE and have been doing for quite some time between our two offices looks at a lot of these very important issues. So, really, we see our initiative going forward is to support that goal, but how do we do that? So I think we need to be able to demonstrate some innovative charging and infrastructure technology for all types of EV owners. And along with that is trying to meet another administration initiative, which is improving equitable access to the benefits of electrified transportation, including underserved and underrepresented communities. So that's an important aspect. And the other part is how do we, thinking about resiliency, we were talking before everybody got on about the nor'easter that went through, but how do we demonstrate some innovations that help to enhance community resilience? Again, looking at that need for underserved communities to really understand, what are some of the challenges and hazards when you start looking at things like distributed solar, energy storage, DERs, and those types of things. So very timely, relevant discussions. Hats off to NASEO, to Cassie and her team for putting these together, and very happy to be a part of it. Thanks, Cassie.
Thanks so much, Mark. And so I think with that, we're going to dive into the discussion with our first panel. And so I would like to invite Chris, Irwin, Scott, Christina, and Husaninder, to join us. The rest of the folks can feel free to turn your cameras off, but we're going to get started with a conversation on grid impacts and electric system considerations for EVs. And so this is obviously top of mind for a lot of particular state energy offices, and the PUCs on the line charging station investments have been long happening, but now the advent of a potentially massive influx of EV chargers, as well as the up and coming medium and heavy duty electrification, there is going to be a lot of need for some advanced planning and coordination between the electric side of the house and the EV side of the house. And so with that, we're going to get started with Chris from the Department of Energy, who will share some information from OE. And Chris, I will bring up your slides now.
All right, thank you. I think it's coming up. Excellent. Thank you very much, Cassie, and I'm glad to be here. This is a fascinating time, you know, it's want to be able to say up front is that we actually do play nice with each other inside of the building, and we have a lot of shared boundaries as the grid continues to become more sophisticated and society evolves its relationship with energy and electricity in specific. So what I'm going to talk to you about is something that we just finished in collaboration with the Vehicle Technologies Office, some work that we are doing now, and some of the things that we can hope to do in the future. So I also wanted to acknowledge that much of this information is done in direct collaboration with my colleague Lee Slezak in the Vehicle Technologies Office. I also work with Mark Smith on other opportunities as well. So we've got a lot going on in between our offices to make sure that we're on the same page. So we can move to the next slide, please. So the information that really just hit the street is that the Office of Electricity for about a decade has been producing what we call Voices of Experience reports. It is not research, it is not roadmap. It really is a survey of the stakeholder experiences, and it is really the direct experience of people wrestling with the issue today. We've done it for advanced metering infrastructure, and our most recent one has been on this EV future. We, of course, partnered with Vehicle Technologies Office to do this because the stakeholders span our boundaries. We wanted to engage folks on these discussions, much in the way that NASEO is now doing with their membership. Get a feel for the lay of the land, the challenges that we should be able to anticipate so that everybody is better prepared to meet the future when it comes to them, because it is not going to be uniform when it arrives on your shores. We're all projecting the same thing, is looking at EV charging infrastructure sort of exploding across the United States and really proliferating. That report was really just released last week, I believe. And so it is posted on smartgrid.gov under our Voices of Experience link. And we have the initiative there as well. And with that, we can move to the next slide, please. We did our best to leave no stone unturned. And so we really got excellent representation across the country, both from utility participants themselves, which OE has sort of a vested interest in, but all of the stakeholder groups that we tried to capture, from government to academia to research and the vendors, the aggregators, the EVSE suppliers, and the like. So we feel like we did a good job of surveying this initial landscape as it, of course, rapidly develops underneath of us. Next slide, please. So rather than go into the details of the Voice of Experience report and things like that, a couple things that we came out with is that, of course, the pace of change is unparalleled. It's also important to note that this is not the only energy revolution happening. We have distributed energy resources. We have photovoltaics coming onto people's rooftops. The emergence of cost-effective energy storage, both at grid scale and at the customer level. So we have a lot of revolutions taking place, and so that pace of change is something that's difficult for slower moving deliberative bodies such as utilities and government to think about. Really, one size is absolutely not going to fit all. And so ultimately, everything that you hear today is going to have to be lensed through your local experience. Your utilities will be different. Sometimes the vendors will be different. The customers may have different needs, and your state legislature may have different priorities. And so it's really going to have a lot of customization. And so the tools that DOE or NREL or other folks create are going to have to be very flexible. This transition is more about just sustainability and low carbon. We have to make it make economic sense because of the number of participants in the system. Is that pursuing decarbonization for the sake of a better world is an excellent start. We also have to make it make economic sense because of the number and diversity of participants that we have. Businesses are going to rely on utilities in brand new ways. Their fuel will be coming from electricity. It could be self-generated, but it may very well be coming from the utility. And electric vehicles are big animals in the electricity consumption business. And so we have to think about them in advance. It's not as easy as dropping DC fast chargers across the region and assuming that the poles and wires and assets are going to be able to hold up under the strain. So those new reliances, new relationships and things like that are going to be a challenge. And we heard from some of our stakeholders that, companies like FedEx, people with fleets and things like that, really don't even know who to contact in all the territories that they operate in. And so you're going to have to become visible as a utility in other places. And of course, the state energy offices are going to see how to bring those stakeholders together. There are going to be tensions in the way that we evolve, because fueling is, anybody can create fueling stations in the fossil fuel industry. There are lots and lots and lots of players. Not all players will embrace electrification at the same rate. And so there will be competitive advantages and disadvantages that will play across. And that's before you start thinking about electric versus fossil supply chains and things like that. There is a great proliferation of uncertainty. And so that's worth thinking about. And of course, that task is going to fall to you at the state energy offices in many ways in the program implementation. With that, I think we can move to the next slide because I want to be cognizant of the time of my fellow panelists. The electric sector was designed, it was structurally created to fund stationary assets. Buildings and homes is where electricity flowed for the most part. Almost nothing has flowed to electric vehicles. So when electric vehicles start to take load from the system, it's fairly predictable and fine. But when we have enormous draws of energy being entirely mobile, sometimes on the verge of being equivalent to a building as they move from place to place, as is the case for heavy duty vehicles and school buses, it changes the way the grid ought to be thought of and how it ought to be designed. And so we need to be thinking about that unpredictability at multiple levels. Social justice requires special attention. Is in many cases, as I'll show on the next slide, is some of the places where electricity is used the least today is where we could do the most good with electric vehicles tomorrow. And so we will have issues that we need to think of very carefully when it comes to making sure that our infrastructure in low to middle income communities is as prepared for vehicle electrification as our well-off or commercial areas are. Utilities play at the center of it, and that's a good thing in the most part. They're very deliberative professional organizations. Not always the fastest animals in the barn, and so we need to think about how to anticipate change and make this transition effective. Obviously, fleets are going to be a big issue that we need to think about. And then finally, the shortage of skilled workers. In our group that helped us guide, our industry panel that helped guide the Voices of Experience report, 3 of the 14 participants switched jobs during the time that they were helping us pay attention to this report. And so there's great liquidity of experts in this area. And so we need to figure out when we go to a state implementation, how to support those implementations and get the professional assistance that you need in order to move forward. Finally, I just wanted to close, if we could move over to the final slide, is being an engineer, I have to finish with a slightly technical bent, is that we've kind of done a meta-analysis of today, what portions of our electric infrastructure by the voltages that we serve are instantly ready for the electric vehicle revolution. Up at the top at the 230, 115, and 66 kilovolt levels, this is what you see in the transmission lines. And really what you see is, as the revolution begins and proceeds, is the transmission system is in many ways better prepared to handle the loads on the system. We have a lot of capacity, we have a lot of generation. It doesn't mean we have no problems, but we are ready to anticipate the change and adapt to it. The closer we get to the customer, the lower the voltage goes onto those poles and wires that feed the individual houses, the more sensitivity that we have in terms of those specific distribution infrastructures to support vehicle electrification. And so down at the bottom level, where you have 4,000 volt distribution systems, which we have in many places in the country, is a few electric vehicles can make the difference between a wide open distribution feeder and a heavily congested distribution feeder. So as state energy officers, you need to think about how can our state plan work for all of our citizens and work for all of the utilities who are going to be part of this transition. And so there will be economic, policy, social, and plain old engineering issues that we need to confront. And I'm hoping that we can all do it together. Thank you very much.
Thank you, Krish. We appreciate the overview. And just a note to our panelists as well as to the folks on the line, you should feel free to ask clarifying questions throughout after each of the presentations. And then as noted earlier, we'll also be diving into a discussion following the presentations. And so, not seeing any questions in the chat, I'm going to turn it to our next speaker, Christina with Georgia Transmission Corporation, to share a little bit about what is happening in their service territory. Christina?
For some reason, my mute button got stuck. So good afternoon, everyone. So just to give you a little bit of background about Georgia Transmission with respect to Georgia, we in Georgia actually have an integrated transmission system, which means that the municipalities, along with Georgia Power and the electric member cooperatives, actually own the transmission grid. So it's actually an integrated transmission system, meaning that any distribution company in the state of Georgia can actually connect to the transmission grid and take service. So if we can go to the next slide. So one of the things that I think it's important to talk about is how are electric vehicles really going to be impacting the transmission and the distribution systems. And so looking at the future of things, what I consider is the distribution impacts, the transmission impacts, also looking at solar power co-location, and going back to the previous presenter, looking at the energy storage part of all of this. When we consider this from a utility perspective, what we're really thinking about is what is the impact going to be from not only serving the customer now, but how that's going to look like serving the customer in the future. And I think it's really important that these presentations seem to be dovetailing into each other, which means that we're on the right track in terms of our messaging. On the residential EV side, you know, one of the things that I try to stress with my distribution co-ops is specifically, you know, we want to understand how we can manage the charging so that although the increase in consumption is there, the increase to demand, which then relates to the increase in more capital on the distribution side, is how can we manage that charging? With respect to electric fleet conversion, the picture does become a little bit more murky and much more complex. As utilities in the state of Georgia, we build to meet the load. But we know these electric fleet conversions are coming down and we have to be prepared. We're looking forward to what are the Class 8 vehicles going to be with respect to impact? What is the impact of last mile delivery? And then what is going to be the impact further down the road for vehicle to grid charging? These are some of the questions that we have to ask ourselves and be very prepared to answer. Next slide. So if we look at the residential electric charging, what we're really looking at is right now, we know that about 78% of that charging actually happens at the home. And so for utilities, we want to go ahead and focus that as the primary location. But we understand that there are going to be opportunities, especially in this multifamily range and hard to reach communities. Specifically, what we're looking at is as-built environments. We know that the hard to reach communities are going to be ones that a lot of these bills are going to be trying to reach. And how is that infrastructure, that distribution infrastructure, going to be put in play, especially on an as-built environment? We know that for a new construction, it's very easy, or it's easier, I should say, to come in and set up for an electric vehicle network for charging. But on multifamily, and especially in as-built environments, townhomes, condominiums, apartments, this is going to be a much more difficult question to answer. As utilities, we really do need to consider managed charging solutions. We need this in order to not only manage the grid, but also manage the generation and manage the demand that's coming on the system. And it's one of those efforts where we need to look at that and have that conversation very early with customers. I have 2 electric vehicles, and I know from my own experience that I like to come home, I like to plug in the vehicle because I don't want to forget and not charge it. And so that's a pattern. And I myself have developed that poor patterning. But I know as we move forward with this conversation, we're really going to have to look at is how we set up with managed charging. Some of the things we have to look at is, from a policy issue, can we supplement work charging initiatives? The reason why I think work charging is very important in this conversation is because work charging is actually considered a benefit. And like all benefits that your company offers, it becomes taxable at some point in time. And so, but we don't want to have a hesitancy from EV owners with charging at work. We want to make charging at work seamless, and we want it to be affordable. And so there has to be some work around, this whole concept of, can we provide charging in the workplace? And then we have to have justification for low use locations. One of the things that we as utilities are looking at is we understand that for us, this is another appliance that is connecting to our grid system. We view it that way. But we also know that this is something that may have low use locations. And so for a utility, we have to figure out a way to provide the service to the infrastructure. Even though that infrastructure is needed, it may not be used at some of the other rates, such as home and workplace charging. Next slide, please. So this comes from courtesy of our friends at UPS, and many people don't know, but one of the original fleets for UPS was actually electric. And so we had found this picture from 1936, and we found out that UPS actually they were at the forefront of electric vehicle charging. And so this is part of what their new fleets are looking like. And so when we start talking about the last mile fleets and what the impact to the grid is, we have to think about how fast our customers are going to be converting to electric vehicles and how fast we can provide that service to them. Next slide, please. So here's what we see coming down the pipeline. So for small distribution centers, what we're really thinking is these will be in the 2.5 megawatt range. We're looking at probably in a situation for a utility, you would come in and you may be able to serve this load with 1 3 MVA pad mount transformer, or you may be able to serve it with, depending on how the campus is set up, you may be able to serve it with 2 1500 kVA transformers. But we do think that this will be in the 2.5 megawatt range. When we move to large distribution centers, I think this is where the conversation really has to become a lot more descriptive. We're thinking that these will come in and around the 40 megawatt to 50 megawatt range. For my utility folks on the discussion, this is quite a bit of load. We would liken this maybe to the size of a mid-sized university campus. So this is a considerable amount of load. These would be your central hub or long haul or inland container ports. Here in Georgia, we have an inland container port, and if that was to electrify, then we would probably see these types of loads. And then there's these opportunities for these electric islands, these kind of pop-up facilities where they would be multi-use, where school buses or Class 8 or delivery trucks could come in and maybe use some sort of billing system where they could swipe a card as a driver and be able to go ahead and actually charge. And we anticipate those loads coming in about 5 megawatts. So in the state of Georgia, one of the things that we're working on is we're actually looking at our system and considering exactly how many of these large distribution centers we have. So here we have public supermarkets. They have about 30, maybe 40 docking stations. And so what would happen if all of those came in and docked? And we're looking at where those locational hotspots are going to be. And from those locational hotspots, we're then looking at the transmission grid to determine what the effects of the transmission, what the effects those loads will have on the transmission system. So for companies or other utilities, I would encourage you to look at your system and make those types of considerations. Think about where your distribution centers are. Here in Georgia, we have quite a few large distribution centers that have current Class 8 vehicles parked there. And so considering if this particular customer decided to electrify, what are going to be my impacts? And that's how we're looking at our locational hotspots. Next slide, please. So managing the risk. I think each of us has to take into consideration what our risks are and what are our opportunities to mitigate those risks. So of course, the most obvious coming out of the gate is transmission and distribution system overloads. Increased demand charges, lead time. With all of the supply chain challenges that we're having right now, if our customers begin to electrify, lead times are going to really prohibit us from meeting that load. Outdated policies, guidelines, and procedures. This electrification is going to be fast. In some places, it's going to be slower, but it gives right now is the time to start really considering, do my policies and procedures address the items that are coming towards us as a utility? Do I need to make changes so that I can meet this load? Associate education. All of us need to be thinking about, do I have the in-house expertise that I need? Do I need to start training my people? And increase staffing requirements. When these loads come, I don't think it's going to give us the opportunity to staff up at that point. It's almost like you have to staff up before the loads come. You have to start that time now to say, what are going to be my staffing requirements as these customers come online? So these are some of the opportunities that I'm looking at, and I encourage others to look at as well. Identify your potential locational hotspots. Manage customer demand profiles. Have those conversations with your customers in terms of what do their delivery schedules look like? Is there any input you can give into those delivery schedules so that you can manage the customer profile or assist them in understanding how we do our business? This one, with respect to review construction lead times, I think is very, very important. Many cases, our customers that are contacting us, they may say, well, we'd like to do this, or we have an order in and we're going to do this work in the next 6 to 12 months. And our construction lead times may be 18 to 24 months. So you really do need to review your construction lead times and have that conversation with your customers. Consider supply chain blankets. Now is the time that if you have a supply chain that you're looking at and you say, we may want to go ahead and get some more equipment now so that we can meet some of these customer demands. This is where your supply chain blankets could definitely take the lead and put you at the forefront of meeting these customer loads. Again, create or update your policies, review your rates. I know there's going to be a very lengthy conversation after the break on rate reviews, but do review your rates. And then the last one, I think, which is the most important, is create appropriate customer touch points. We have to get out there and tell our message to our customers. I always say, if you have a 1,000 square foot house and you're going to put on a 1,000 square foot addition, you would contact your local utility. You would contact your electrician and he would contact your local utility. But you would never make the assumption that your existing breaker panel would feed the 1,000 square foot addition. Well, on the commercial side, maybe some of our customers may not know that that's the case. They may not understand that they have to contact us, and they may not even further understand that they need to contact us much earlier in the process so that we have an opportunity to meet their requirements. So I think creating those appropriate customer touch points is vital. Next slide. And I think that's the end of yes, it is very wonderful. The end of my presentation.
Thank you, Christina. We did have a question in the chat, just a clarifying question on your presentation. In terms of large distribution centers, how would you classify that in terms of loading docks or trucks per day?
So, we haven't been able to actually put our hands on how large these vehicles are going to be. But I'm considering that to be anywhere from 15 to maybe 30, 40 vehicles. It'll be very interesting when the Class 8 vehicles actually come online. We know that the last mile delivery, we know that's going to be in the 2.5 megawatt to 6 megawatt range. We don't expect it to be much bigger than that. The Class 8 vehicles definitely, based on the size of the customers that we currently have and how many loading docks that they currently have, they could have anywhere from 20 to 40 to 60 Class 8 vehicles showing up at the facility. And one of the things that I think is going to really cause havoc on the distribution and transmission system is that you may have this intermittent charging where you have one vehicle will come in and it's sitting there charging. And you're thinking, okay, well, this will be the load, but then another vehicle will come in and charge. And if we've learned anything from the residential side of the house, a lot of that initial charging to get you to 80% happens in the first couple hours. And then it kind of, drains off. So it'll be very interesting, but I'm definitely looking at these customers being in that, in the 30 to 40 vehicle range. So I think for our considerations, we're looking at those types of vehicles. Or what I should say is those types of facilities that are handling those distribution. And, in Georgia, we're fortunate in a way that we have quite a few of these. So it'll be very interesting for us to be able to model them and share them with everyone else.
Great, thank you. I am seeing a few other questions coming in through the chat. I think in the interest of time, we are going to hold those for right now. And so we will come back to those at the end of the presentation. So thank you, Christina. And so now I'd like to turn it over to Scott to share a little bit about what is happening with LEDWP. Scott?
Great. All right. So for those of you that may not know about LEDWP, Los Angeles Department of Water and Power, we're the largest municipal utility in the country, and we provide water and power to the 4 million citizens of Los Angeles. We're a vertically integrated utility, so we own, operate, and maintain our generation, transmission, and distribution. We have about 8,000 megawatts of capacity, and our peak load is about 6,500 megawatts. Next slide. So I'm going to kind of just briefly touch on what EV adoption and charging infrastructure goals look like for the state, and more specifically the city of Los Angeles, discuss what we see as some of the distribution system impacts related to EV charging, a little bit about what our strategic thinking and planning is on electric transportation, and then just kind of touch on EV rate designs that we've been looking at recently. Next, please. And you can just go right to the next slide. So in the state of California, a lot is being driven by a recently adopted executive order from the governor, and it's going to require, or it requires, automotive dealers to end the sale of new fossil fuel light-duty passenger vehicles by 2035. And then electrifying freight trucks by 2035, also, and medium and heavy duty fleets completely by 2045. So pretty aggressive. What we thought was maybe originally a year ago as being aspirational, I think it's becoming more real. The OEMs are all in, and This is already happening in other countries. So we kind of see it. It's going to play out in California, and it's going to spread across the country. So, the California Air Resources Board is now enacting, or the process through a rulemaking process will be adopting regulations to really enforce these requirements. So, what's sort of playing out is, so what does it look like as far as the EV charging infrastructure that's going to be required to kind of support this effort? So, Assembly Bill 2127 really put in place a comprehensive study performed by the California Energy Commission and really the work being done by NREL to look at what charging is going to look like for the state. So, 700,000 public and shared private EV chargers needed to support 5 million EVs by 2030, and then even a little bit more aggressive part of that is the 1.2 million chargers to support 7.5 million EVs by 2030. So it's part of the ARB's mobile source strategy. So City of Los Angeles is about 10% of the state. So we kind of see our goal numbers as really being about 10% of these numbers. So pretty significant. Next slide, please. So this is a snapshot of LEDWP's transportation electrification goals. 250,000 light duty electric vehicles and 4,000 medium heavy duty by 2025, 550,000 by 2028. And this continues to kind of ramp up. So the commercial EV charging infrastructure requirements, 45,000 chargers by 2025, 1,000 of those being DCFCs, 120,000 by 2030, and that's 3,000 fast chargers. So that's the 1.2 million for the state. That's the 10%. It's 120,000. And then the city has adopted outside of the state some electrification requirements for the city's fleet. So it's really, where technically feasible, it's 100% of the entire city fleet by 2028. So that coincides with the Olympics. Next slide, please. So here's kind of what it looks like as far as the commercial EV charging station numbers. We're at about 14,000 here in the city, and these are kind of the previous goals, even before the AB 2127. We've now revised them, so you kind of see this 11-fold increase since 2018. So it's ramping up. And if you go to the next slide, please, you'll kind of see these new goals that reflect what the state has adopted in this AB 2127 study. So, right there at 14, you kind of see where we were previously, way above kind of the targets. Now we're just kind of right on this line, and you kind of see this ramp as being pretty steep here by 2030. This 120,000 commercial EV charging stations here in the city of Los Angeles. So this is obviously, these are commercial chargers. These are, public, workplace, and MUD chargers here in the city. So we have a lot of work to do, and we're pretty confident we're going to get there. Next slide, please. So another kind of snapshot here. LA 100 is a study, a very comprehensive study that was just completed, also done by NREL specifically for LEDWP, to look at how do we get to 100% renewable energy here in the city. So, our goal is to get there by 2035. EVs are a big part of that. You kind of see these different cases: a moderate and a high. What was once the high case is now becoming more kind of our base case, if you will. And this is the number of plug-in electric vehicles in the city of Los Angeles. The top line there in black is the total light duty vehicles in LA, about 3 million. Next slide. So, and it's not just light duty, it's also medium and heavy duty. You know, the Air Resources Board is right now in the process of adopting regulations that are going to require, you know, the sale of medium and heavy duty electric vehicles in the state, ramping up. It's pretty aggressive. And then as part of that, there's going to be a fleet regulatory requirement. So fleets are going to have to start transitioning over to electric. So you kind of see these scenarios and these curves here. We've had EPRI kind of look at this for us. And there's a breakdown by, you know, class 2 to class 8. There's school buses and transit buses. Already in place as a requirement that all transit buses be electrified here. Actually, it's not just the city, but it's the entire state. But in the city, it's going to be 2030. So we're on our way to kind of make that happen. Both the LA Department of Transportation and LA Metro here are in the process of installing those charging facilities to make that happen, and they're starting to integrate those electric buses into their fleet. So those are pretty big electrification efforts, as you can imagine. You know, 5 to 10 megawatts at a site to kind of really support those types of efforts. Next slide, please. So you can roll to the next slide. This is kind of getting into the distribution issue. You know, our distribution system is really two voltages, 4.8 kV and a 34.5 system. The 4.8 is really for residential and small commercial. 34.5 is for the larger commercial facilities. So, you know, we right now are seeing about 100 megawatts. We figure, and that's going to ramp up by 2030 to about 500, and then out to 2045. We kind of see this as just ramping up to, you know, in the order of maybe 2,000 megawatts on our system. That's the coincident EV charging from electric transportation. Next slide. So there's a lot of work that's going to need to occur to really get our distribution system ready to support these types of numbers. You know, we know that we need to upgrade our feeders and our circuits on the 4.8, 34.5 system. We're going to have to add new distribution station capacity, upgrade our receiving stations, and we're also looking at a voltage conversion. So we may bump our 4.8 kV system up to a 12 kV system. So that is something that will be a big lift for us, but we're starting to look at that. And not just for transportation electrification, but just for all electrification, and to really kind of support the renewable effort. Next slide. So this is sort of a snapshot of what we kind of see as what uncontrolled charging would look like. Pop up there, you see some curves for weekday and weekend, that 2,000 megawatt number, 2045 that I was kind of talking about. It's uncontrolled. You know, this is the scenario where people come home and they plug in, and you know, between 4 and 9, when we're at 100% renewable, and that's a lot of solar. You know, that's part of the duck curve that we don't want people to be charging on. So the lower on the bottom there for weekday and weekend, you'll see these curves. These are the kind of the managed EV charging, if you will, where we kind of shift the charging to time periods that can be supported much easier with our system. Next slide. So talk a little bit about some strategic planning and some initiatives we have underway as we kind of facilitate transportation electrification. We kind of see it as being very important on educating our customers on the benefits of electric vehicles. You know, available rebates and resources, incentives, and ultimately really trying to influence charging behavior. So, we want to prepare our customers, especially those who are interested in becoming EV owners, and eventually we think it's going to be everyone. So, next slide. So I'll just kind of touch on some rebate programs we've had in place for several years. We right now are providing our residential customers rebates for level 2 charger installations. It's towards the purchase of a charger, is $500. If they put in a dedicated meter for that EV charger, we'll provide another $250. We have right now in place a used electric vehicle incentive. It's $1,500 towards the purchase of a used electric vehicle. This is really kind of an equity issue, and the state has in place incentives for new vehicles, and then there obviously are federal tax credits and other incentives for new. So, we wanted to really kind of incentivize this used electric vehicle market to address some equity issues. Next slide. So for the commercial EV chargers that I kind of mentioned, we have a number of rebates that are part of the suite. For level 2 EV chargers for workplace and MUDs and public charging, we provide $4,000 towards the purchase and installation of a charger. It's $5,000 if it's in a disadvantaged community. So it's a pretty attractive rebate for customers. They can get up to 40 if they have the required number of parking spaces. So it's $200,000 per site, and for DC fast charging, up to $75,000 towards the purchase and installation of the charger. For medium and heavy duty, it's $125,000 towards the purchase installation of the charger. So this up to depends on the power rating of those chargers. So this is the maximum amount. Next slide, please. So a little bit about what we're doing on rates. We currently have, actually, for our residential customers, we have it's a 2.5 cent per kilowatt hour discount off of the off-peak charging rate. We have a separately metered service for your EV charger. And then for commercial customers, we just recently passed some pilot rates. And really the goal of this is to encourage EV adoption, attract charging station service providers, whether it's Electrify America, EVgo, Tesla, or Green Lots, to really kind of come in and put in these DC fast charge plazas in the city. So, and we also want to, of course, promote fleet electrification and offer affordable rates. So, next slide. The rate options are really kind of broken down into two. There's they still have demand charge components, although we've really reduced the demand charge because it was really we were getting a lot of feedback from customers for large EV plaza charging DC fast charge customers that the demand charges were really providing a disincentive for them to install these in the city of Los Angeles. So we sort of reduced the demand charge impact, kind of rolled it more into the energy charges, although we still have some demand charge elements there. But we kind of brought the rates kind of more in line with what other utilities are offering here in the state of California on EV charging. And next slide. So a little bit of a shift on these special pilot offerings. Our current commercial TOU rates have this sort of this peak period, if you will, of 1 to 5 p.m. We are now shifting that for this pilot offering, and it's more kind of consistent with what other utilities are doing in California. And this is that sort of that renewable and solar issue where we want to basically we want customers to kind of stay out of that 4 to 9 p.m. Range, if you will. So kind of see the shift here. And next slide. It's kind of a snapshot of ultimately what these rates look like in kind of comparison to what other utilities are doing in California. So for a large customer, you know, with the roll-in demand and other components, they're saying it's about 21 cents a kilowatt hour. So we think that's a pretty attractive rate, although it probably sounds a lot higher than what other utilities charge across the country. There are some nice low carbon fuel standard credits here in California that get generated, and those credits actually have a value of about 15 to 20 cents a kilowatt hour. So you generate those credits and you get to sell those back into the marketplace. And actually, those rebates that I kind of mentioned that we were offering, those are all being funded by those the low carbon fuel standard credits, LCFS credits. So to date, it's about $100 million for us just in the city of Los Angeles, LEDWP. And I think that's it. Next slide. And that's it for my presentation. Thank you.
Thank you so much, Scott. We did have a number of clarifying questions coming through the chat, so you should feel free to take a look at those and respond as needed. In the interest of time, though, I think we will go on to our last speaker. And Husaninder, if you'd like to camera on and share a little.
Yep. Can you hear me? Okay.
Yes, we can.
All right. Thank you. Just maybe for those who don't know, I'll just reintroduce. I'm with DTE Energy. DTE has about 2 million customer base distribution utility in southeastern Michigan. We cover the Detroit metro area, and I think one of the point I will be mentioning or referring to, we are the automotive hub with a lot of automotive employees and automotive production here. So first of all, I think I'll start with the problem here we are facing, or the challenge that's in front of us. We have started looking at EVs at a higher level, at a system level, from the generation planning quite a while ago. It's a part of our planning process. We used to have a separate forecast for our distribution planning, but our newest effort is to create an integrated forecast system. So we have a granular view of the system forecast, which is at a system level. Utilizing one of our assets is the AMI data. We have deployed AMI throughout our customer base, and we have good data that we can utilize. So we are on the forecast front, we are kind of combining and consolidating the top-down approach and also bringing the bottom-up approach using the AMI data. So what we are looking at, it's still, the future is very uncertain when it comes to time and how many EVs we are predicting or forecasting are going to come in. And I would say I will spend a little more time on the distribution side, as Christina touched on the transmission side of the problems and the larger facilities. I'll go more into the residential. And my history a little bit is in distribution planning as well. So I apologize in advance if I get a little bit too technical, but I think it's good points to understand the challenges that are coming on the distribution system. So like I said, continuing on the forecast, we are looking at traditional ways of forecasting. Maybe a couple things that are very unique to our service area is we being the automotive hub, we get a lot of employee discounts and a lot of executive leases that can accelerate the penetration or adoption of EVs very quickly. also presents a challenge from if you have done like some propensity studies in other states, which are typically based on the consumer demographics. We have to include some additional things like who works for automotives, where they live, and how likely they're going to adopt the EVs. So we are looking at that. Also, when you look at the distribution system, the impacts start at the grid edge. What I mean by that, I think from the DOE slide earlier, you saw the voltage levels and how the lower voltages are more in the red. So we are at the lower voltages at the distribution edge, grid edge, where your house or residence is served by a transformer. We typically may have anywhere from 5 to 10 customers on a transformer, depending on a size of the transformer. EVs added onto that can complicate things very quickly, from anywhere to the first EV added on the transformer to second or third. Then we are looking into problems. We are going to have to upgrade the transformers or look at what's going on with the refeed or reconfigure the system to handle those EVs. So I'm gonna, so just kind of breaking into it, one of the complicated uncertainty coming into the play is not only with the rate of adoption of EVs, not only with when they're gonna come and how much charging they're gonna need, because everybody drives different miles, right? If I'm driving 60 miles a day or 100 miles a day, my charging need is gonna be very different from somebody who drives 2 to 5 miles or 10 miles a day. So we are, that uncertainty is there. Plus what is happening recently, we have been following the big three, the GM, Ford, Chryslers in Detroit. We started all the level 2 chargers we saw in the previous presentations are like 6 or 7 kilowatts type of range. What we have seen with as these new vehicles come, for example, Cadillac's Lyric, or we have Ford's F-150 Lightning, they have about 11 to 12 kilowatt charger. Any extended range vehicles like the Ford F-150 will have 19 kilowatt charger as a standard. So to put it in perspective, a 2,500 square foot home, and here in Michigan, at least, our peak demand of that house is about 4 to 6 kilowatts. And now you bring in a 19 kilowatt charger, you can imagine what's happening to your demand. No way any of the distribution assets are designed to handle those kind of chargers, even if we get into time of use or anything else. I think I'm not discounting the time of use or charging management. I think what I'm differentiating is at a system level, those things make a big difference for generating assets and even for higher level distribution assets. But at the grid edge, the transformers feeding the residences or the secondary wires feeding the residences are going to see the impact earliest compared to any other grid assets on the system. So, and so that was kind of the setup of the problem and the uncertainties we are dealing with, what's coming in future. There's no talks of any chargers more than 19 kilowatts yet, but we still will see how the things evolve. And so we are trying to come up with an approach that is more flexible and will get us ready and also help us serve the needs as they arise. One thing we adopted recently in our distribution planning is a scenario-based planning. What it does is instead of going into like a probabilistic planning and trying to figure out what's going to happen when and get the system ready for it, we try to come up with the 3 scenarios, so 3 scenarios that are discrete and they're plausible futures. Our 3 scenarios were electrification, The second part was distributed generation and distributed storage. And the third scenario is the resilience from increasing or changing climate or increasing intensity of storms. We look at what are the solutions that serve us well and get us ready in multiple scenarios instead of optimizing for one scenario. And that guided us into developing set of like a no regret solutions that can help us to be ready in the multiple scenarios, how they play out in future. So the part of the EV scenario is you still get to plausible EV forecast and try to identify the grid impacts and what are the gaps we have so far. The biggest thing is the forecasting and still in the EV market. We still want to be ready for the next EV that comes on and plugs in, right? We don't want to, nobody is gonna like hearing, hey, you cannot charge the car because we still need to get the grid ready for it. So it'll be maybe a few months or like Christina got into the lead times. We need to be ready for it. So we are looking at some of the transformational changes to our approach, how we deal with this problem. One of the ones we kicked off recently, very new, we haven't done too much development into it, is using our AMI data, using the AMI data to figure out where EVs are coming on. So that's one of the approach. We still have not nailed it down perfectly yet, but I think we have an opportunity. Either we can use, I don't want to just throw in buzzwords, but can we use some deep learning models or artificial intelligence models to look at the AMI data and do our advanced analytics on it, see where the EVs are coming on and what pattern they come in. So use that data to figure out what are the next predicted locations and what is the impact on the distribution assets. So for example, a transformer in an area is now identified. It does not have a capacity for integrating another electric vehicle, but it is a high propensity area. So we will have at least a direction to figure out which assets we need to upgrade and when. So I think it is a approach to optimize the most. I think we are still looking at what are the most equitable ways. We don't try to fall in for, hey, EVs are being adopted by, the equity issue are being adopted by people who can afford it today. I don't know exactly what tomorrow holds, but I have a feeling that or we will come up with the equitable way of EV adoption. So we want to keep it open on the low income neighborhoods or wherever they come up next, we are ready for them. So the second part that I was going to touch on is the user data. So we have been looking at a lot of the data is available, such as EV registration data we have. So we need to get more granular with the data we have. EV registration data is a lot of times is available at a zip code level. We need to get into miles driven data if we are going to figure out what are going to be the demand loads. I think one of the things we have been looking at is when consumers make decisions to buy electric vehicles, they do think about maybe once a year trip they take across the state and it's a 400-mile trip. And that's how they make a decision which car to buy, not based on 360 days of the year, how they're going to be using. So we need to figure out what are the miles driven and what are the anticipated loads coming from that. The second thing that we have been looking at is we have had a good success in one of the Bring Your Own Device program. It's a demand side management program. We allowed customers with smart thermostats to enroll in our demand side management, where they will allow us to increase the temperature, decreasing the demand during the peak times. We had a tremendous success because the way we end up going about it is we went with the vendors or the manufacturers of the thermostats for enrolling customers and managing it. And what we have figured out, the user interface is so easy. You just hit a button, enable, and you're on it. I think the similar approach with charging, we have looked into EV management, charging management systems. Typically, they've been looked at for fleets, but if we can get into with the GM or Ford or Chrysler, Tesla, if they can manage the charging from the software in the charger or the car and let users manage the charging. Hey, you need 10 miles of range or 100 miles of range every day. It'll be ready by 8 a.m. in the morning. The management, you just come in and plug, but when actually the charging happens, it's all behind the scenes. I think there are going to be a lot of good options and success there. So more to, we are developing on those, but there's going to be a lot of investment into propensity studies. It's going to be a time thing, how soon we are ready for what levels of EV. But I think that's all I have. We are into that grid edge readiness right now. We are gearing up for the system level readiness, which we think it's going to be a little bit of time there for us to have things roll up to the system level. We do have a lot of efforts. We right now in DT Energy Service Territory, we have 4.8 kV and 13 kV voltage. So we are looking at how can we employ a higher level voltage if that is going to help or if that is a solution. Because in the end, I have been thinking about it. Back in the day, 4 kV or 5 kV systems were really popular. And it was 60s when the central air conditioning took off. So that central air conditioning is most of your, going back to the 2,500 square foot home, most of your 6 kilowatt load is central air, which is usually 4-ish, 5-ish kilowatts. Now, if you think about future like 2035 or 2050, I think it is going to be a similar kind of transformation where EVs are going to be that kind of load in all of the households. So we are going to have to look at some of those things that we looked in the 60s to do we need higher voltage? And these things may change, they will, I think, they will change the distribution system, how we design it and how we operate it every day.
Wonderful. Well, thank you so much for your comments and to all of our speakers. Just a note on time, I know that we are already rapidly approaching the end of the session, but we do want to allow some time for a discussion. And so we will be shifting our break back a little bit. And so with that, I'd like to invite our panelists as well as the participants on screen to turn on their cameras and we'll begin a discussion. And so before we kind of jump into questions from the states and the panelists, I wanted to turn to Tom or Corinne to see if they have any comments that they would like to share from Greenlots and EVgo. I know that on the customer side, there's a lot of needs in terms of local upgrades, et cetera. So would welcome any thoughts from the private sector.
Sure. Well, thanks, Cassie. I'll maybe lead off. So I think, I just wanted to reflect on a few things that I heard, and certainly I think are, well aligned with how Greenlots is thinking about opportunities and challenges out there. So I think, first of all, there's a very strong message that utilities have a very central role to play in the electrification of our transportation sector. I think there was also a pretty clear message that that's not just pressing a button. It takes time, it takes planning, and yes, it takes time on the side of the utilities, but in terms of market participants, customers, et cetera, it takes time there. And the sooner that, those conversations can be happening between folks who are thinking about either transitioning to EVs or needing to deploy EV charging infrastructure and utilities as well as charging providers, the better. I think what I also heard was a fairly clear theme around the importance of managing charging and the significant load that we're likely to see around transportation electrification. You'll probably hear a little bit more from me on that later in talking about rate design, but would just acknowledge that You know, there are a lot of different approaches to doing that. It can look like a lot of different things. Greenlots is a provider of technology approaches for managing charging. Utilities are also providers of technology approaches as well as rate approaches. And I, for one anyway, maybe speaking for myself a little bit more than Greenlots, I'm really excited about the opportunity to provide choices to drivers and site hosts about how to manage charging and how to provide different options for cost savings in some cases, or indeed passing through costs in other cases, and providing a price signal to consumers. I'll just end by saying that I'm certainly encouraged in sort of seeing a lot of the clear thinking around this topic. You know, Greenlots is based here in Los Angeles, so work fairly closely with Scott and his team and organization, but we'll also reinforce some of the goals that Scott shared. Those were LEDWP goals within the context of LA and then the state of California. And I do know there are a number of states represented today, maybe in listen-only mode, that may not have goals for deploying either EVs or, more importantly, charging infrastructure. So as a market participant charging provider who works with utilities who are trying to plan, the sooner that we can all kind of develop goals to provide more clarity around sort of the speed and scale necessary for planning, the easier this is going to be for all of us.
Thank you, Tom. And Irwin, if you'd like to weigh in.
Yeah, sure. Not able to turn on my video, so I apologize about that. But I not very much there to add. I really agree with Tom's comment about starting the conversation sooner rather than later, and really thinking. I mean, I think that in general, I would say that there is quite a large group of stakeholders, including utilities, state agencies, charging providers, that all have and continue to have concerted efforts going on to try to scale up infrastructure and meet policy objectives and market demands, and where we can try to get ahead of inefficiencies, of delays in the early stages of planning and interconnection, and really trying to work together early on. I think the better that process is. And I know that there's quite a few utilities that have ramped up on their efforts, even as something as simple as ramping up their staffing and creating dedicated teams to address and work specifically on EV/SE projects. And that has a really important impact. And I think that in terms of best practices, I know that some utilities have also worked on providing maps to provide some kind of a picture around grid capacity and to try to decrease the need for upgrades in utility transformers. And that's something that I think has been and will continue to be extremely valuable. The other thing that I just wanted to mention, and I believe this is Husaninder who's just mentioned this from DTE, about thinking when we talk about infrastructure, we should think about sort of the 364 days of how we use an EV rather than the once a year trip. And I think that kind of brings to me the idea of when we talk about the EV network, really considering and giving consideration for community charging in and around sort of day-to-day activities as much as corridor charging, and then just kind of different types of deployments and different types of needs, I guess, to provide or to address. So yeah, just wanted to mention those two things, but really appreciate what I've heard today on from the different presentations.
Thank you. And just a note, folks can feel free to use the raise hand if you'd like to jump in with a question or a comment. That'll help us to kind of organize the conversation. But Ben, I noticed that you had a comment / question in the chat, which ties quite nicely into a theme that we've been hearing from a lot of states around the need to ensure that the grid as well as EV charging infrastructure is resilient. And so I'm wondering if you'd like to share a little bit about what's happening in your state on that, and if you have a question for the group.
Yeah, no, I appreciate that, Cassie, and thanks for the presentations before. Yeah, my question really just centers around kind of resiliency and, some of these outlooks that we're looking at of, 2030, 2040, 2050, which is not really that far away, right, in terms of grid planning and grid implementation. So my question kind of centers around the effects of, extreme weather, extreme climate impacts that we're having here in South Carolina, where, we'll have high tide flooding just on a sunny day, or certainly we've got projections of up to 4 feet of sea level rise in Charleston. So my question kind of goes around to the utility, grid considerations. With this EV charging infrastructure, should we be looking at grid tied solutions, or should we be looking at more of the free wire, non-grid tied DER solutions that can be for EV infrastructure? So I don't really have an answer there, but I'm interested to see what others may have and what the utilities may be thinking of.
I'll put in my 2 cents because I'm not a utility. It's a difficult arena and so we have to sort of plan for that future, and we have to be able to sort of model it and predict it, because you really don't want to have the most expensive solution. You want to have the most efficient solution that accomplishes your needs and things like that. So I know that in advance of the Texas blackouts is that many of the EVs anticipated the weather event and loaded up and fully charged their vehicles before the event hit, which is great for evacuations. It's great for bridging yourself across those divides and things like that. That's really the most efficient thing, because you're drawing energy from this social resource, which is the grid. Those standalone issues, like say microgrids and things like that, have a big role in resilience plays that have a secondary payer or a primary payer, like a hospital or a school or something like that. If it's merely for transport resilience, then you've got a very expensive asset that will see almost no use. And so that's the trick. But obviously the highways were planned for evacuation corridors and things like that. And we need to anticipate that there will be electric vehicles on those evacuation corridors and think about those dimensions.
And absolutely. And to that point about evacuation corridors, I was talking to a charging provider the other day, and they can see when evacuations happen in our state, they can see folks coming from other states to charge in our state from their evacuation efforts. So I'm not only planning for the vehicles that we have in our state, but certainly the ones that can cross borders.
Thank you. I'd like to open it up to the other states on the line to share any concerns that they've been seeing in their energy planning. Chris?
And it fits well with the planning. One of the things that had come up in Hawaii last year at our legislature had been mandate to convert rental fleets. And so we heard Hertz just make that announcement, which made it a little more real. But one of the things that we've done is looked at what would the load impact be of converting a rental fleet, and saw it could be roughly like 10 megawatts. And so I was wondering, what advice do you have on finding these hotspot load customers that can really have significant system and significant kind of load pocket issues?
Sounds like it's a stumper.
I guess we're also thinking in terms of electric aviation as well, that we're seeing more of. So it's just kind of identifying these specific customers that are going to have unique profiles, but significant loads that are coming on, and trying to get out ahead of it.
Mm-hmm. And Christina, it sounds like you have worked extensively with some of the customers to identify that level of load. I'm wondering if you have comments on this.
So with the respect to the customers with the level of load, and I guess I'd like to touch back on the DER initiative. You know, one of the things that I'm very curious about, as always, are there complementary use cases, specifically around how can we co-locate facilities or co-locate use cases where we can really maximize the benefit. I think it kind of teased off of what Chris was alluding to is, you know, one of the things I'd like to know is, you know, where are my facilities that need a DER initiative, especially if there is a disaster, if they're a designated disaster relief area? You know, I think that that's very intriguing to me, because then all of a sudden, from a resiliency perspective, you understand exactly where you need to facilitate putting in a resiliency solution. So I like those concepts. I like the concept, especially around schools. Like if you have a specific school that is a designated disaster facility for people coming in from different parts. I think it dovetails into what kind of Chris was alluding to, but it's a challenge for utilities, right? So I think some of these concepts are very interesting, and it's something that we have to get into. And there's actually some more, there's actually Scott Woodward had put out something that I was reading. It says, until DER can provide a much better cost for storage, DER will not meet the changing charging needs currently. And kind of keying off of that, I do think that we have to look as when DER expands beyond, you know, especially in the battery energy storage area where we get beyond 4 hours. You know, we have to start looking at, in my presentation, I pointed to the kind of the longer duration times when we start getting into the 10 hours. And then it really starts to support some of these resiliency solutions. I don't know if that answered the question, but those are kind of my thoughts, because I really like what some of the things that Chris alluded to. But I think this co-location of facilities is really what I think is intriguing, and using a variety of use cases to justify what we're doing, I think, is imperative.
Thank you. I know that we are rapidly approaching our break. We'll have that in a few minutes. But before we do, I did just want to pose a question to the group. There is potentially going to be billions available for EV charging station investment, potentially billions available for grid and infrastructure upgrades. And I'm wondering what opportunities there are to ensure that EV planning and grid and electric system planning is meshed and is coordinated. It's not often that the same planners are involved in both fields. And so would welcome thoughts from the panelists, but also some of the states on the line. And Marion, I'm wondering if we could actually turn to you to just share any thoughts that you have. You've been a commissioner as well as the director of a state energy office, and I'm wondering what your experience is with coordinated EV infrastructure investment planning and grid planning.
Yeah, thank you so much, Cassie, and thanks to all the panelists. This is super interesting. And I know as a former regulator in a part of the country with very high electricity rates and a pretty good infrastructure, you know, we're not very big. We're not nearly as big as Los Angeles geographically. So we have a lot of charging for the number of electric vehicles that we have right now. We are very concerned about getting out in front of the load. And I heard a number of people, Husaninder and Christina, both mentioned, you know, the amount of load that one EV will add to a household. It's like, okay, get out in front of that and set up some price signals so that consumers, folks who are charging their vehicles, will charge at a time where you don't need to expand the distribution system. And I think I'm very heartened to hear the utilities starting to do that kind of work. I know DOE has been pushing for it for a long time, and we're starting to see that kind of integrated planning. Very complicated, but a great opportunity for folks who are good modelers. So pilot programs, I think we're going to get into that in the next session. And what we found, the last thing I'll say in Rhode Island, is that consumers our EV owners have been found to be quite responsive to price signals, especially if coupled with some good educational materials.
So Cassie, I just wanted to put in a good word, is that you can give us advice all day long, especially, you know, to DOE and stuff like that. Sometimes we'll hear it, sometimes we'll hear it and write it down, sometimes we'll hear it, write it down, and it'll make it into the report. one thing that is, should the infrastructure bill come to pass and should EV charging and grid modernization be a part of that, is that there will be, without a doubt, a request for information process where we solicit to the public, how can we craft our grant instruments to fulfill the national mission? That is the time when we as government agencies need to be told by one or many voices that you ought to think about synchronizing grant mechanisms across agencies, because in the vehicle electrification case, Department of Transportation may be getting those funds and DOE may be getting grid modernization funds. So we have to be told to play nice together in a public forum as a constructive recommendation for the future.
Great, thank you. And I think that that's a good note to end this panel on. And so a big thank you to our panelists for providing such interesting information.